See here, we have a small cup with a dry piece of paper inside and a large container full of water. I'm going to place the cup straight down into the container, all the way to the bottom. But you would think the water would fill it, considering that the water goes all the way up to my hand. But as we pull the paper out, let the water drip off, we see that the paper remained. My wet hand will speak. The paper remained entirely dry. Magic.
Air is occupying space inside the small cup, whether it is upside down or right side up. Because air is occupying space inside the cup, the water cannot enter the cup even when completely underwater, and thus the paper stays dry.
Check this out. Ready?
So Andrew's blowing between two sheets of paper, and the papers are moving towards each other instead of away from each other. You'd think that the papers would move away from each other, but because of Bernoulli's principle, they're not. Bernoulli's principle is that faster moving gases result in less pressure on whatever's pushing against it. So since the air is moving faster between the papers than outside the papers, the stronger air pressure is making the papers push together. As Andrew pulls the beaker towards the edge of the table, you'd think that the beaker is going to fall off the table as it reaches the edge. But it does not. The reason it does not is because of inertia and friction. A slow pull gives enough friction between the paper and the beaker so that the beaker stays on the paper. The water in the beaker makes it heavier, and the heavier the object, the greater its inertia. That's why it works easier with the water in it. The tabletop and the bottom of the beaker being smooth reduces the amount of friction that exists when the paper is pulled.
You get shot. It got messy.